Okay, greetings and salutations, my friends. I'm so excited to have you with me to watch this video. And today we're going to learn about the heart. I was going to say the human heart, but really I'm talking about any mammalian heart. So that's a heart with 4 chambers. And if you don't know what that means, don't worry. We're going to learn because we're going to look at a bunch of different models of hearts. And that's what I have in front of me. So if you're ready, let's go. Okay, so the first model we're going to talk about is one you're probably pretty familiar with if you have ever experienced Valentine's Day, and it's this one. And all I really have to say about this model of the heart is, although we recognize it as a heart, it's not particularly helpful for us to understand what's going on inside the body or really anything. So this first model. Okay, now the next model of the heart I'd like to talk to you about is one of these. And I'm sure you've seen one of these delicious things before. And you might recognize this as a strawberry. But that's not a really great name to really describe what it is because it doesn't look like a straw, does it? But do you know what it does look like? It looks like a heart. It looks a lot like a heart. And our First Nations, the Anishinaabe people, they called this Odamen. And if you break that word down, Ode means heart, Min is berry. So this translates directly to heartberry. And let's think about this as a model for the heart. Well, it's actually better in that this is the shape of a heart. So if you compare this to, say, this model here, or spoilers, our actual heart, you can see there's a definite similarity in shape. If we look at this, we definitely have a bottom pointy bit, which is called the apex. We have a top bit with stuff growing out of it, which is called the base. I know it's a little bit confusing that the base is at the top, but these sepals, these little green leaves, they could be considered like the vessels coming out of the top of the heart. So pretty good model. Let's look inside of our heartberry. So as you can see with our heartberry here, I'm going to cut it open. And what do we find inside of it? Hopefully, oh, we do have it a little bit. We have chambers, which is French for rooms, chambre. So we have little chambers inside. We have 1, 2. Now, as the heartberry develops, those little chambers kind of get bigger, but you can imagine that we have something that on the inside is a little bit hollow in places. Well, guess what? So is the heart, because the heart is a pump. And I believe, therefore, this particular model is a better model. And in addition to that, it's also it's also delicious. As a little side note, yes, eat the green leaves on top of the strawberries. They're not bad for you at all. And they give you a little roughage, a little vitamins, a little minerals that you don't get in the rest of the berries. So eat the whole darn thing. Odamen. As a little side note, in Anishinaabe culture, each of the moons are named for something that's happening at a particular time. And the full moon in June is called Odamen Gizis, which translates to heartberry moon. Because in June, that's when the strawberries are blooming. And that is 100% the absolute best moon there is. Odamen Gizis. Peace. Alrighty then, let's move along in heart models. And this is an actual model of a heart. So it's much bigger than a human heart would be, probably about the size of maybe a rhinoceros or a hippopotamus, but I don't know for sure. But smaller than an elephant, bigger than a cow, definitely bigger than a human. This is the front part of the heart, called the ventral side. This is the dorsal, which means back. front anterior, back posterior. All right, let's talk about all the features on the heart that are shown here. Now, before I do anything else, let me talk to you about a little bit of a misconception. What color is blood? Well, you might have learned that it can be blue or red, but I'm here to tell you it's never blue, not even if you're in the royal family. It's always a shade of red. We're going to get back into that a little bit more. So let's talk about the parts of the heart. If you look at the surface of the heart, you can see it has blood vessels all over it. These blood vessels, they feed the muscles of the heart with oxygen and nutrients. If these blood vessels get blocked, then part of your heart can die, and that's what we call a heart attack. So it's also sometimes called a coronary infarction, which sounds like a swear word. But a coronary, as it's sometimes shortened to, is when one of these coronary arteries gets blocked or damaged. So now let's talk about the top part of the heart. This is the trunk, and the trunk is sometimes the base of a tree. It's also sometimes called the base of the heart. And this is the pulmonary trunk. And frankly, if you look at it, it kind of looks like a highway off-ramp. Like, look at all of these, like, these arteries and veins crossing over each other, just sort of like a highway off-ramp. It's a little bit confusing. I'm going to try and pull off vessels one by one to sort of show you what they do. Now, this one here, boom, is called the pulmonary vein. Now, veins carry blood away from, pulmonary artery, my bad. They carry blood away from the heart, away. Now, the reason why I called it the pulmonary vein, and I was slightly confused, this is the only artery in the body that actually has deoxygenated blood, which we represent as blue. And you see how it splits? Like, so it comes out of the heart from here, and then it splits. So it can go to either lung. So there's your pulmonary artery, only artery in the body with deoxygenated blood, in case you didn't know that. Now let's look at this one here. This one here is gigantic, okay? And I'm going to pull this whole section off here because that's sort of how it comes apart. This one here is the aorta. And it's gigantic. Actually, a whale's aorta is big enough you could stick your head in there. This is an aorta, and it carries oxygenated blood away from the heart to the rest of the body. And you can even see it starts to have branches coming off. This branch would go down your left arm. This branch would go down your right arm. This branch would go to your head. If there's something going wrong with your heart, this is the closest branch where you first feel things. That's why they say sometimes you feel a tingling in your left arm. That's not love. That's a heart attack. Okay, so your aorta, little gross bit of information. I've been told that if your aorta gets severed, it will shoot blood about 2 meters up in the air. So that's the pressure in there. And Grand Theft Auto actually represents that kind of accurately when you do a headshot in Grand Theft Auto, but I get it. TMI. Let's move on. Now, it's telling me all about the blood vessels that are feeding the heart. Not quite. So we've got this blood vessel coming in from the top of the body. This is a vein. And then here we have this blood vessel coming in from the bottom of the body. And these two bring blood back into the body. And they're actually not called veins. They're called vena cava, which I like to say is Latin for a vein as big as a cave. Although, to be entirely honest, I don't know that that's what it translates to, but it's a good way to remember. Now, this is the superior vena cava, because it comes from above, superior. This is the inferior vena cava, because it comes from below. It's inferior. It's not really inferior, it just comes from below. Now, are you ready to get into the heart? I hope so. Here we are, we're getting inside the heart. When we get inside the heart, I feel the need to do a fake British accent. All right, let's talk. So when you're traveling into the heart, the first room, so think of a mammalian heart, that's the heart of a mammal. It has 4 chambers, 4 rooms inside of it. And different types of organisms have different numbers of chambers in their hearts. Birds and reptiles have 3, Fish have 2. So there's different types of hearts, but ours is a little bit more complex. And the first room you go into is the atrium. And let me show you into the atrium. Boom. Now you can't actually do this with your heart because you would die, but I can pull off bits of the heart and we can look inside. So if you look here, these are the atria. That's plural for atrium, and that means rooms. This is the right atrium, and this is the left atrium. And I always put the heart on my body to remember, and because it's based on like from your perspective, left and right. So right, left might look different from you at home. So the blood collects in here, coming from the body. The blood collects in here, coming back from the lungs. And these things here are called the pulmonary veins that bring blood back into the atrium. And you'll notice they're red, which means they're oxygenated. This is the only vein in the body that carries oxygenated blood. Just like the pulmonary artery is the only artery that carries deoxygenated blood, because the blood goes to the lungs, gets oxygenated, and comes back. When the blood goes to the body, it gets deoxygenated. All the oxygen gets lost, and it goes here. So let's talk about the journey of deoxygenated blood. Now we're going to look inside. You can see these walls here, not very thick, not very muscly. And when we look at the actual heart, you'll see that a little bit more. I'm going to pull this off, and I'm going to reveal the inside of the heart. And what do we see? We see a couple of things. And we have 2 more muscly chambers on the right side and the left side. This here is called the right ventricle, and this is called the left ventricle. Now notice, before we move on, the muscle on the wall of the right ventricle is thinner than the muscle on the wall of the left ventricle. Also, look inside here. You see these little things? My assistant Ryrat called them beards. But they're not beards, they're valves. And what they do is they only allow the blood to flow in one direction. So when the blood squishes, and this is how a heart beats, it goes that's the sound your heart makes. Well, that's not actually the sound your heart makes, is it? The sound your heart makes is boom, 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 boom. And what is the sound you're actually hearing? The sound is the sound of your valves slamming shut. So when the atrium pushes the blood down, squishes it all down into the ventricle fills with blood, and then the ventricle pushes it. And when it leaves the left side, it goes out here. This is where the pulmonary artery is. And when it pumps out of the blood here, it's a little bit harder to see, but it comes up through here, and it comes out the aorta at the top. And there's also a valve in each of these blood vessels to prevent blood from flowing backwards. Because what happens is this. Blood squishes down, you don't hear a sound. Then when this ventricle starts to contract, these valves slam shut and you hear pump. All right? And then after this ventricle relaxes, the blood might start to suck back through these blood vessels. These valves close and you hear pump. So what do you hear? Pump, 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 pump. What's making the sound of a heartbeat? Your valves shutting. Why does the doctor listen to your heart? They want to hear if everything's okay. If there's a problem with your heart, it might go boom, boom, shh. Oh no, the blood's leaking backwards. It might go boom, shh. Oh, this valve has a problem. So that's why we listen to the heart. These are also called your heartstrings. And if someone's tugging on your heartstrings, they're making your heart beat faster. And don't tug on your heartstrings too fast because you'll break the model, which I just did. But I'm going to glue that back on later. So I will fix that. Okay, you can see this heartstring was already broken. Okay, and that is everything I want to talk to you about the functioning of a model of the heart. We're now going to move on to the real heart. Oh, yeah. Okay, my friends, now we are moving on to the actual pig's heart. And I'm pretty excited about this. The thing about a pig's heart that's kind of cool is it really is about the size of a human heart. So if you want to know how big your heart is, just take a fist and put your other hand over it. And it's roughly the size of your heart, and this is where it sits. You can see it sits in nicely. If you're a smaller person, the heart's going to be a little bit smaller. I actually purchased this heart from a butcher, so shout out to Sanigan's Meat Locker, and they put this heart aside for me. I really appreciate it. $6.99, great price. Actually, I have no idea if that's a great price for a pig's heart, but it was worth it. Now, the heart's a little bloody, and though my friends sometimes call me Pigpen, because I do tend to make a bit of a mess. So I'll tell you what I'm going to do. I'm going to put on this lab coat, and I'm going to be very, very careful removing the heart from the bag. I'll see you shortly on the other side. Okay, so we got the heart out of the bag, and that did not go very well. How did I get pig's blood on my head? What is this, Carrie? Okay. Now, before I go on to talk about the actual heart itself, let's dispel the rumor that blood is ever blue. So this is blood that's deoxygenated, okay? So deoxygenated blood, and you can see it's red. Whoop. It's red. And that is not blue at all, is it? It's red. We represent it as blue just because it's easier to sort of distinguish between the colors. And blood that's oxygenated is less brown and more crimson. So that's the difference between these two things. Now, let's move on to talking about the actual pig's heart here. Oh, looking at the pig's heart, and we are looking at the front side, or the ventral anterior surface. If we compare it to our actual model, you can sort of look at the blood vessels and how they go, like the coronary artery, coronary vein, and you can see that they kind of match up. So it's one way we can know we're in the front. And looking at the top, they've actually cut it open. So you're looking right into the atria, and they've kind of cut off that whole pulmonary trunk here. Also, why do we use models like this? It's way easier to find stuff on this than it is to find stuff on this. But if you really want to be good with science and these things, you have to be able to understand this, because you're never going to cut something open and find one of these. So we have to figure out this. Now, this stuff on the surface, this white stuff, is fat. And it actually pads the heart. So we need to have a little layer of fat on the surface of our heart. And they've actually cut open the pig's heart already, so that's been done for us. You can see this is the base. The apex here is a little bit pointy. Here, let me line it up so you can see how it was. It's a little bit pointy at the bottom, but rounded. And let's open it up and look inside. Boop! If someone ever says their heart is like an open book, you know, you should probably talk to a doctor, because that's not good. My heart is like an open book. Oh my gosh, you're gonna die. Okay, let's see, what do we find inside the heart? Well, a couple of things we find. First of all, looking up into, going from this is an atrium here, okay? This here, this little flap, okay? This is the left atrium, and there's a vessel in here, there's muscles in here that pull the atrium shut, and it's a lot smaller. There's all sorts of space in here, and then when it squeezes shut, these muscles just pull down, pushes blood into the ventricle, and if the blood wanted to flow backwards, it would hit up against this valve, and the valve would shut. And these are the heartstrings that we talked about. I'm playing your heartstrings. Oh my gosh, look how they flay out like that. Isn't that cool? Did you see that? Let's see that one more time. So I can make all the heartstrings go together, or I can pull them apart. And these are all tendons, chorda tendoni. And these here, this tissue is the heart valve. And because a pig's heart is basically the same size as a human's heart, we can actually replace a human's heart valve with a pig's heart valve. Now, this is all the muscle on the left side. You can see that the left ventricle is significantly thicker than the right ventricle. There's the right ventricle. You're looking inside the right ventricle. The right atrium was kind of wrecked a little bit, but there's a bit of it up here. Okay, this is the right atrium. It was sort of cut right open, but you can see the detail of all the way the muscle is in the wall of the atrium, whereas the muscle in the wall of the ventricle's way thicker. Well, why is that? Because in the atrium, you only have to push the blood this far, right? The blood coming out the right side of the heart, a little bit thinner walls of muscles, only has to push the blood to the lungs. That's not very far. I'll show you on my body, right? Heart's here, lungs are here. That's not very far. But on the left side, look how much thicker the muscle is on the left side. That's because when the blood pushes out of the aorta, which is right up here, when the blood pushes out of the aorta, it's got to travel all the way through the body and have enough pressure to make its way back. So a much, much stronger push from the left side. Also, as a left-handed person, I'm going to tell you a little fact. Left side better than right side. That's my own personal prejudice. That's probably only held by about 10% of the population, but there you go. So, speaking of there you go, that's the heart. What are we going to do with this afterwards? We're not going to waste this. So we will be making a little pig's heart stew. And that's just as delicious as it sounds. And we have to cook it for an awfully long time because this meat will be very tough, but also edible. So I'll see you at the dinner table. I hope you enjoyed the heart dissection. Peace!